All right, so let's say that we have some arbitrary angle theta. Then let's call this point xy right here. All right, so we will draw our triangle, our right triangle, by dropping this perpendicular. All right, how long is the hypotenuse of the triangle? So this is a unit circle. That means its hypotenuse would be 1. All right, how long is this side of the triangle? Well, if this point is xy, then this distance would be x from here to here. And this side of the triangle would be y. All right, so what famous theorem relates the three sides of a right triangle? Well, that's a good old Pythagorean theorem, which in this case would say that x squared plus y squared is equal to 1 squared. So we have x squared plus y squared equals 1. All right, remember our definition of sine and cosine. So cosine was the x value of this point, and sine was the y value of this point. Therefore, we could say that cosine of theta squared, and then y is sine. Sine of theta squared equals 1. Okay, so this is a very famous trig identity, and by identity I mean that this is true for any angle theta. Any angle you plug in will make this true. An abbreviation that's used for this term, cosine of theta squared. Okay, so cosine of theta in parentheses, then you square it. People often write it like this, and sine squared theta. So if you put the 2 here, cosine squared theta, that means this. It means cosine of theta squared. I know it's kind of a weird spot to write it, but people often abbreviate it that way. All right, so very famous trig identity, and one that we will use a lot, and you need to make sure you know by heart, and of course know why it's true. Sine squared theta plus cosine squared theta equals 1. All the time for any angle theta.